Let's do maximum depth of binary tree. So given the root of a binary tree, return its maximum depth. Now this is just like basically the longest path that you can go down starting from the root. For example, the answer for this is 3, so you can start from 3, you can go to 20, and then you can either go to 15 or 7. They'll both give you a node count of 3. Not many people asking this, but still important to know, so let's get to it. So since this is a binary tree question, you might think to use DFS, and you can, but I think the DFS implementation is kind of confusing. And I think in my opinion, a less confusing way to go about it is to look at the levels of the tree. So as you can see, this is the first level, this is the second level, this is the third level. So the answer is basically just the number of levels in the tree. So if you count first, second, third, that's the answer, 3. So we can do this actually with BFS. Now I still think DFS is more prevalent, but just in this case, we'll be using BFS because it's less confusing in my opinion. So let's start off by making a queue. And in this queue, we're going to initialize it with the root. Now, next, what we're going to do is we're going to just do a simple BFS. And this is probably also important to remember, just like DFS, because it's just like a boilerplate algorithm that you can apply to a lot of different problems. So we're going to say while queue, and inside this, we're going to iterate through the length of the queue. So we say for underscore in range, and then length of the queue. And we do this because this is basically the condition for it to go breadth first. Because this range function, it only calculates the range value on the first iteration of this for loop. So for example, if it calculated that there were, there was one element in here, it wouldn't update that, even if the length of the queue changed. So it's really good for just adding all the children and then going through the length of the current queue, and that gets basically the current level of the tree. So now what we want to do is we want to pop the next node from the queue. So I'm just going to call it current, and then we do queue.pop left, right? And this gets the first element in line. So it's going to get root in this case. And then after that, we want to check if the current node is null. So if it's null, then we just don't want to do anything because it's going to lead to errors down the road. So we say if not cur, then we just continue. And if cur isn't null, then we proceed with the following, which is we check if cur.left. And if cur.left exists, then we also add that to the queue. So we do queue.append cur.left, and then the same thing for cur.right. So to get the maximum depth, what we actually have to do is make a variable. So I'm going to call it levels. And as I said before, this is basically BFS in order to get the number of levels, which is actually equal to the maximum depth. So after an iteration, we just want to increase levels by 1. So it's just levels plus equals 1. And then we can actually just return levels. Seems like we have an edge case here where the root is empty. So we're just going to say in the beginning, if not root, then we want to just return 0. And then that's basically it.